Okay, in today's video we're going to be introducing the 30-day series where we'll be doing a project from scratch. We'll be basically doing the a servo system, basically a fully emulated system with state logic. We'll be doing an HMI system tying together so you have full HMI control. Be showing everything start to finish. So without further ado, we'll go ahead and start day one. So basically what we're going to do is we're going to start up our emulator, and we'll just get that running in the background. Then we'll open up 5000. And first and foremost, we'll make our program. This would be a new program. So basically we'll select version 20. I am going to start making videos after this, probably on version 30. But we'll keep all this at version 20 for right now. So we'll just say YouTube 30-day project. That way everybody can keep track of everything. And we'll just keep our chassis slots and everything in the same spot. So anyway, so this will start the program. We'll go ahead and let this make, and as soon as it makes, we'll go ahead and do our first pass of what, the highlight things that I like to do to make sure things are right. So this will be a time scheme situation. So again, I'm going to be using like a state logic situation. More or less, it's going to be a situation where it's a state input, state output array, not just necessarily a general state transition. So it'll be a state transition, but with basically an input-output array. When we dig into that portion, you'll understand exactly what I'm talking about. But first and foremost, we're going to change our main task from continuous to periodic. Being that we're running an emulator, we'll basically we'll want to take our watchdog up a little bit, and then we'll keep this 75 milliseconds. And in the main task, we're going to call this axis task. So this is where we'll basically be doing all our axis programming. And then we'll make another task, and then again periodic, and then we'll call this machine control, and then basically we'll put this at 45 milliseconds. So we have two tasks right now. We'll go ahead and make a new program. Again, we'll main routine, or actually this would be main program. So main program that already exists, main machine. Let's just say main. Tell you what, let's change this. Let's change this to. I'd rather see this different. That way it keeps in suit of what we're doing, and then that way we can keep this as in suit as far as that goes, and we'll come back and add our main routine. Okay, so now we don't want it structured text. We want to make sure that it's ladder logic. So make sure that we go down here and open up properties, and in properties we're going to configure. Make sure that your main routine is your main in that, and same thing in axis. Generally speaking, when you see the one with the basically it's like a notepad or whatever on the ladder, that does indicate that it is selected as the main program. You know, if you were to change that, you would see that goes away. So that's a good indication. I just like to verify that and kind of go through things in a little bit more detail. Being that we do have 30 days to do this, we want to make sure we go through everything in good detail. So again, we'll have access task. We're going to have the machine control, and then we'll basically have we're going to have the probably do like a virtual access scenario. So let's do that too. So add a new task. So we'll call this the virtual master, and we'll keep this the same. So again, not event driven. We want to keep this. Keep this periodic, and we'll change the timing scheme a little bit. So let's keep this around like 50. But again, you want to keep the we're running an emulator, so you want to keep the watchdog rather high. And then we'll make sure we did that on that one as well. I don't know if I went ahead and did that. So we're doing that because it's basically it's an emulated process. We're not actually having a processor. So virtual Okay, so we'll go ahead and throw that in there, and we'll throw in the main program again. Okay, so basically all we have so far is we have our access task where we'll be doing all our access stuff. We have our machine control where we'll be doing the machine control. We have our virtual access where we'll be doing like speed control. And we will have one more, which is basically state driven. So we'll come in here and we'll call this the state machine, and we'll have the state machine at a, let's just put this at like an 80. And I may change these times. Right now I'm just going to throw default times in there just to kind of get the ball rolling. So state main. Let's call it state machine main. Okay, so and then we'll throw our main program in that. And it says it already exists in the state machine, which I don't think it does. Okay. Oh, I see what I did. Yeah. Okay, so sorry about that. Alright, so to kind of go over it, recap, if you looked at this periodically, right now what we'll do is we'll come back and we'll throw our time schemes behind it. So we'll say 75 milliseconds. We'll call this whatever we have it. Currently we have it 47, so we'll say 47 milliseconds. And this is just to kind of keep the base understanding about this. So we kind of, it's easy to keep track of stuff. So 80, and it's just a good, good feature to have. when you're looking on the outside, you don't have to keep digging in the control properties. And then we have this one at 50, so 15 milliseconds. Alright, so look at that. We have our timing schemes in here right now, and we are starting to develop our program. So just to kind of give a hierarchy of what we've done so far, what we want to do too, being that this is a servo system, you want to come back and again, date and time. You want to enable time synchronization. And that's very critical in a servo system that you do that, so that the servo timing is done correctly. Naturally in a processor, everything would be derived off the date and time. So the date and time would be populated, and you would have hit the set date and time off workstation, or that, so it's not a default value. Generally speaking, when you make one, you download it to a processor. Brand new processor is going to have like maybe a 1990 something date and time. So you want to have it as current as possible, just to keep it in real time. Now, not necessarily like it won't work, because it will still work. It's just a matter of just keeping it a good practice, right? So just note that you don't see that now. I'm running an emulator, so you may or may not see that. So we'll come down here and we have our motion groups. We're going to throw in our axis and stuff of that nature. We'll come down and basically throw in our UDT. So the next step we're going to be doing is throwing in our axis. We'll be throwing in all of our axes that we're going to be controlling. This would be basically, I'll probably do 5 axes, and I'll probably do 1 as the virtual master. I'll probably do 4 others that will be driven off of that, and then we will change the set up the attributes and of that nature, as far as that goes. So this whole machine will be showing everything of that nature. Once we're done, we'll show how to use the control task, and we'll set up all of our routines and stuff of that nature to control the system. We'll have a state system as far as the state machine in and out, like a sectional state machine, and then we'll have again our axis task, which will be controlling the on-off fault resets, stuff of that nature. So in the next videos, what you'll be seeing in the next video after this is I'll be doing the starting of the HMI system, and then I'll come back and finish out. I'll add my axes on day 3 and my UDT on day 3, and then we'll come back and keep adding on each day. We'll add on more and more of elements in this program, so that we get a better understanding of what's going on. So again, this is just about hitting the 15-minute mark, and I want to keep these kind of close to the 15-minute mark as possible, so that we get one day at a time. We kind of make good progress, and we don't draw this thing out. We could probably knock all this out one evening, but honestly that would take way too much time. So let's just keep this around 14 to 16, maybe 18 minutes at the most. We're right at that 14-minute mark right now. So again, to recap, you see what we did so far. The next videos will be showing the HMI. And then the video after that, which would be day 3, we'll be doing the UDT, and then we'll be adding our axes. Okay, so real quick, I just want to thank you for watching, and we'll be going ahead and making the other videos, and they'll be posting daily. So if you want to fall back and check those out. If you catch this late in the time, or if you somehow later on in a couple of days, I'll be posting the other videos as they stagger down. I'll be posting them in the show notes below. Okay, so again, thank you for your time, and thank you for your support. And if hopefully this is going to be very, very helpful to show, as far as start from scratch. All right, well, and we'll catch you tomorrow, and catch another video. Thank you.